So now we get to probably the most important number in all of linear algebra, and that is the rank of a matrix. So let me define what it is. Definition. Okay, so for a matrix A, the rank of A is written like this and defined to be the number of non-zero rows in a row echelon form of A. Or equivalently, it is equal to the number of leading entries in a row echelon form of A. I'm going to box this because it's super important. Well, all the definitions I make are going to be super important. Later, we'll see that this rank is the same. This rank is the same for all row echelon forms of A. Before going on to why rank is so important, I want to make one more definition. So let's see. If I have, for instance, some notation. So for instance, if I have something like 1, 2, 3, 4, 5, 6, minus 1, minus 2, I often will abbreviate this like this. So here, this A right here, that's just this matrix here. And we often call this the coefficient matrix. And then this B here, that's this guy here. There's not really a standard name. Some people call it the right-hand side vector, but I don't know if I'm going to use a specific name for it. All right, so why do I like the rank so much? And that's something we'll begin to see from the following theorem. Let me move things up a little bit. Maybe we'll move it down a little bit so you can see the definition of rank. There we go. All right. Theorem. And this is theorem 2.2. Let A be the coefficient matrix of a linear system with n variables. System with n variables. Variable starts with an V. Variables. Variables. If the system is consistent, that's very important, if it's consistent. So that's important. So I'm going to double underline this, or actually triple underline because it's extra important. If the system is consistent, then the number of free variables of the system is equal to n minus the rank of the matrix. There's not really anything to prove there, and to see why there's not really anything to prove there, and that's because really that's the definition of free variables. Well, there are a total of n variables, and we know that the rank is the number of leading entries or leading variables, and the remainder is the free variables. Let's move this back up or here a little bit. There's a couple other parts of the theorem. Moreover, if there are no free variables, there's a unique solution. It's not really anything special about rank. It's just the fact that when we write out the solution, if there's no free variables, then we have no parameters. On the other hand, if there are free variables, there's infinitely many solutions. I can do grammar, are infinitely many solutions. Again, both of these are within the context of being consistent.